Welcome to Easy Math with Tammy. Today we shall be looking at a problem on the screen. So we are asked to evaluate this integral if possible. Now this kind of integral is called discontinuous integrand. It's an improper integral. How do I know it's improper integral? So if you check the last video, I talked about an improper integral, and that's a type 1, and the type it's called infinite intervals, and this one it's type 2, which is called discontinuous integrand. How do I know it's discontinuous, right? If you check the interval 0 to 3, you would see that 1 is inclusive, right? And then if you plot 1 in the integrand, you're going to see that you have 1 over infinity and 1 over 0, sorry, 1 over 0, and then 1 over 0 is infinity. It means there's a point of discontinuity in the interval. So there's a way you should solve this kind of problem. However, if you do not consider the point of discontinuity in this kind of integral, you might as well just go ahead and solve it, and then you think the answer you get is actually correct answer, because we can actually solve this directly. So solving this directly, it's like, okay, we're gonna have a ln u-substitution, right? So you have a ln x minus 1 0 3, and then that means it's gonna we're gonna have a ln 2 minus ln 1, and ln 1 is 0, right? And the answer is ln 2. Now this looks like our integral converges because we have an answer. However, we are not so sure because we are not actually dealing with the limit point, so we can't say that this is correct. If you solve it this way, you think, okay, the integral is correct, I got an answer, the integral converges. No, this is not the correct approach to solving this problem. So if you want to solve this problem, you have to use the limit approach, and that's what I will show you in a few minutes. So I'm going to go ahead and erase this. Guys, and then solve it properly. Now I know that the point of discontinuity, right? And the point of discontinuity is 1, right? So what I'm going to do is that I'm going to split the integral. So I'll split it like this. So that's going to be from 0 to 1 dx plus no, sorry, that should be from 1 to 3. Yeah, so I split that. So now I'm going to solve this integral independently. So this is a and this is b, right? Note that if I solve a and I have something that goes to infinity, then I don't need to solve b, right? Because infinity plus anything is infinity, so it doesn't really matter. So, and that implies that the original integral diverges, right? That makes sense. So, but if I have a constant value, then I have to solve b and then merge the answers together, right? So let me go ahead and solve a. So since I know that there's a point of discontinuity at 1, it means that there's a vertical asymptote at 1. So I have to use the limit concept to solve it. So all I have to do, I just call this a. I call this a equal to limit as t goes to 1 negative. Now it's 1 negative because we are actually approaching 1 from the left. It's the upper bound, right? So we are not getting to 1, because if you get to 1, there's a point of discontinuity there. So we are not getting, so we're moving from 0 to 1. So if it's other way around, like if there's the point of discontinuity is at 0, so that means you're approaching 0 from the right. So in that case, it's going to be, let's say, 0 plus. So it's going to be something like this, 0 plus. Yeah, that makes sense. Okay, so I have that, which is 1 minus, and then integral 0 to t dx over x minus 1. So I just integrate this properly using substitution method, right? So okay, using substitution method, so I just say let u equals x minus 1, then I have du equals dx, so I substitute back into the integral. So I have the limit as t goes to -1 0 to t, and this is going to be du over u. So you can as well change the limit point, the end point, right? Or you can just leave it like that, whichever way, still work fine. So this is limit as t goes to 1 negative, and this is going to be ln u, and then our u is x minus 1, so I return that back, and then with a limit point, right? So I can then substitute the limit point, so that's going to be limit as t goes to 1 negative, and that's going to be ln t minus 1 minus ln, that's going to be 0 minus 1, yeah, and then ln 1 is 0, right? So limit t ln 1 is 0. So now all I have to do is to substitute my 1 into that expression, and I have the answer. Now if you plot t minus 1, right, the t minus 1 graph, ln t minus 1 graph is going to look something like this, So we'd see, we can actually see that it's going down to negative infinity, because this is like infinity, so it's going down to negative infinity, right? So what that tells us that when as t goes to -1 of t minus 1, right, the limit as t goes to -1 just of 1 minus t, that goes to 0 plus, and then the limit of that is negative infinity. So, and that tells us that our integral goes to negative infinity. So this is negative infinity. So a equal to negative infinity. Now since we have a to be negative infinity, it implies we don't actually need to solve b anymore, because whatever b is still the same as a negative infinity, and that tells us that our original integral, which is 0 to 3 dx x minus 1 diverges. And now this is how you approach this kind of problem. So you don't have to go ahead and solve it, because if you go ahead and solve it, the answer might actually be wrong. And we could see that when we solve it directly, we have ln 2, which is not the correct answer, because that tells us the integral converges, and that's not true. We can see that the integral diverges. So that's how you solve this kind of problem, which is called discontinuous integrand. So if you enjoy what I've solved and then you like it, ensure that you subscribe, like, and share, and then you enjoy some of my videos. Yeah, thank you. See you in the next one. Bye.